Good afternoon, I'm Genaro Perez Rocha, here reporting you an oil spill in the Mexican Gulf. In 2014, a significant hydrocarbon spill originated from a pipeline under the administration of Refinería de Petróleos Mexicanos, also known as Pemex, an environmental catastrophe. Despite the lack of visual evidence of the spill's consequences, investigations revealed that the refinery continued to discharge wastewater laden with hydrocarbons and oils. A decisive action was made by submitting an official document to the respective authorities, invoking their authority for verification and inspection. Their primary objective was to prompt an evaluation of the refinery's operations, with the aim of formally recognizing the extent of the environmental and social repercussions resulting from the refinery's activities. This dedicated coalition now calls upon experts to conduct comprehensive water quality studies in compliance with the standards outlined in the Normas Oficiales Mexicanas, the NOM, to gain insight into the behavior of the chemical compounds at the heart of this incident and to fully comprehend its environmental impact. A series of questions must be addressed. Now, with you, Diego Grosch.
Thank you, Mr. Perez Rocha. I will now explain a little bit about these two different molecules. Two hydrogen atoms are covalently linked to one oxygen atom to form the polar molecule known as water, H2O. Due to the oxygen atom's greater electronegativity nature compared to hydrogen, the hydrogen atoms have partially positive charges while the oxygen atom has a partially negative charge. That we call in chemistry the vector of polarity. The repulsion between the ion pairs of electrons on the oxygen atom causes the water to be bent, as we can see in the Lewis diagram. It's also called a linear angular structure, with an approximate angle of 104.5 degrees. Determining the various hydrocarbons' physical and chemical characteristics is unique to every molecule because they each have unique structural characteristics. The arrangement of the carbon atoms and the type of bonds that are present affect the melting and boiling points, reactively and generally behavior of hydrocarbons, and variety of chemical reactions. In petrol, we can find a lot of different types of these hydrocarbons. An example of this is C2H6 ethane. Ethane is a non-polar molecule with a VSEPR of a tetrahedral geometry structure. Each carbon reacts with 3 hydrogen and the other carbon, as we see in the Lewis diagram down below.
Thank you, Grosch. I'm Sofia, and I'm gonna explain a little how the intermolecular interactions between hydrocarbons and water have an impact of the oil spill problem. Hydrocarbons and water do not mix. You won't ever see oil or hydrocarbons mixed in water. You will more likely see some bubbles in the water, which show how one is not soluble in the other. These molecules are not soluble between them because of their polarity, since water is polar and hydrocarbons aren't. Hydrocarbons are only made up of hydrogen and carbon, and their non-polar bonds make these molecules hydrophobic, meaning they do not mix in water. The polarity of hydrocarbons is covalent nonpolar because the subtraction of their electronegativity is lower than 0.4. These are insoluble in water because water is a polar solvent, and polar solvents only solve in polar solvents. The density of hydrocarbons depends on the amount of carbons and hydrogen it has. But if we go to our basic hydrocarbon methane, we will find its density a very low density, low level of viscosity, low boiling points, and very volatile. Hydrocarbons are nonpolar, so they aren't soluble with water polar solutions, which is why oil spill is an environmental catastrophe. We're with you, Ms. Medina.
Thank you, Sofia. I'm Mafer, and now here we go to the solution. One solution to the problem is to find more efficient security measures so that these mistakes do not happen. Environmental catastrophes are caused by human mistakes, so the first step is to find better control protocols for systematic mistakes. The government should implement a system for continuous environmental monitoring in areas near oil transport routes. Monitor water quality, soil conditions, and wildlife health to detect any early signs of contamination. In addition, a risk assessment must be made. First, identify potential areas of risk in your oil handling and transportation processes. Point number 2, evaluate the environmental impact of potential spills in various locations. And finally, assess the likelihood of spills occurring based on historical data and current conditions. We must also demand the government's transparency. That means be transparent about your spill prevention efforts and any incidents that may occur, and report spills promptly to the public objectively.
I'm David, and I will give a solution from a chemical approach. A technique that can be used to separate hydrocarbons from water is low-temperature fractionation. This is used to isolate the different components down to their freezing and melting points, taking advantage that different substances within the mixture require different temperatures. You have to freeze this mixture below one of the substance's freezing point, down to where this substance will solidify. Then you have to filtrate the liquid substance and then melt again the solid substance to be separated. Low-temperature fractionation is a method used to separate hydrocarbon mixtures based on the differences in freezing points of their components. It involves cooling the mixture to a temperature below the freezing point of one component, e.g. methane. The first step involves cooling the hydrocarbon mixture to a temperature below the freezing point of one of the components. In this case, the freezing point of methane is at minus 183 degrees Celsius, while water freezes at 0 degrees Celsius. Therefore, you will need to cool the mixture to a temperature below 183 degrees Celsius.
Crude oil and its refined products can contain various hydrocarbons, including some that are toxic. The toxicity of petroleum products depends on their composition and can vary widely. Crude oil spills, for example, can have detrimental effects on aquatic ecosystems and wildlife. The social and environmental impact of this problem is leaving a big mark on our planet, and that is hard to erase. This is a very serious problem, since the leakage of petroleum causes permanent damage in water ecosystems. In addition, when these mistakes are made and they are mainly hidden away rather than trying to solve the problem, humans keep forgetting that it is our responsibility to avoid these mistakes from happening, and that when they happen, we must find a solution to amend the failure to our responsibility with the planet. In our opinion, a very important social impact that this problem has is that the authority doesn't seem to give enough attention and importance to the problem. This entails the spread of apathy in people towards this issue, since the authority doesn't seem to address a definite solution or prevention to this issue. There is a risk of decreasing activism in people regarding this problem. Thank you for your attention, and a shout out to our biggest fan. This is for you, Cesar Zapata.